Hey guys, welcome back. Matt Young here with Flowco, and today we're going to talk about Series 6 Capillary Tubing Understanding. We have guest host today, Keith Cobb.
Hey, how y'all doing?
Man, doing pretty good. Thanks for coming down to talk about this topic with us.
Yeah, oh yeah, it was a long flight.
Yeah, flights out of Midland are always like that. They're either on time or you spend all day in the airport.
Oh yeah.
At least they got a bar there.
Yeah, that's true.
So, guys, today we're going to talk about capillary tubing, really go through the understanding of it, why an operator may run cap tubing,
Right.
what they would do with it, applications behind it, all that kind of fun stuff. And so, as we continue our e-learning series on technical topics, we wanted to kind of branch away from gas lift and plunger lift like we've talked about here lately and go to not really obscure topic, but a topic that I don't think gets enough recognition, especially from like the understanding of why you may want to use it.
Right, agreed.
Yeah. So luckily we have Keith Cobb here, regional spooling manager, to help provide that operational and technical experience on, applications of cap tubing, why you would use it, how to maintain it and
Right.
really keep it going.
Yeah, and what typically we see in the Permian.
Yeah, exactly. Yeah, and get some of that, basin specific experience from you. So, like I mentioned, we want to talk about why we see some or the reasons we see some operators using cap tubing. Of course, we want to talk about how the heck you get the stuff down hole.
Right.
We'll go over a lot of that. And then, of course, once you get it down hole,
What do you do?
what do you do with it? Yeah.
Right.
And usually, like most artificial lift or applications, there is some kind of maintenance schedule or,
Right.
like upkeep to it. And so,
Oh yeah.
really want to go over to that and pick your brain on a lot of things.
Yeah, sounds good.
So, perfect. Like all these trainings, we're recording them. We'll post them up on the website, usually the next day. So if you missed it, if you had to get off, if somebody wasn't able to get on today, this live training, they can always go to the flowco solutions.com and find those recordings there. Guys, like always, we want this open discussion. So if you have any questions while we're going through the presentation, feel free to put them up in the chat function. We got a moderator here helping us keep track of those. Of course, if you want to wait till the end of the presentation and really quiz Keith to see how smart he tells everybody, you guys can ask him at the end. So we'll give ourselves maybe 10, 15 minutes at the end of the presentation.
Well, I'll try.
All right. So today I want to see us stumping Keith on a cap tubing question. So yeah, guys, with that, I think we'll go ahead and get started. You ready, Keith?
Yeah, I'm good.
Perfect. Okay. So like we talked about, we're continuing that e-learning series focused on technical applications. And so today we wanted to branch away from our typical like plunger lift, gas lift, or engineering nodal analysis side and dive into a topic that is either really popular or is completely shunned. And that's kind of how I see capillary tubing. If I go out to Midland, it seems like everybody runs it.
Yeah.
But if I go to say like
The
Eagleford,
yeah, it's completely different.
Exactly.
It's very
So
different.
I kind of want to understand why.
Right.
Maybe it's applications, reservoirs, what the operators need, and so really go through that and pick your brain on all of those questions.
Yeah, sounds
So,
good.
cool. You want to get started?
Let's try.
All right, let's do it. So, when we talk about cap tubing, essentially what it is, right? It's a secondary tubing string in your well.
Correct.
Just a really
slightly smaller.
really tiny tubing string, right? And basin to basin, we kind of see different applications for it, right?
Right.
And like, so in my head, I see a lot of CO2 floods, maybe in the Texas Panhandle
Right.
or San Andreas out there in the Permian, or really down along the Gulf Coast where they're doing a lot of CO2 or WAG floods. Operators use capillary tubing to deliver CO2 into the well. So
Right.
basically they use it like a poor boy gas lift, right?
Right.
Where you can install the cap tubing, typically big sizes, right?
Yeah, typically 1/2 inch or greater.
Okay. And then they'll inject CO2 down that cap tubing just like gas lift, aerate the fluids and produce the well.
That is correct.
Another application that I imagine you're really familiar with is chemical injection, right?
Right, which is typically what you see out in the Permian, Delaware, that area.
Mm-hmm. So in those applications, are running the cap tubing and using it to inject chemical at like a desired depth.
Right, and usually, it's banded on the outside, which we'll
Okay.
get into a little.
Yeah, definitely. We'll talk quite a bit about that. And another application we see a lot of capillary tubing used is mainly in those gas fields like Haynesville, Marcellus, Utica, where they're actually injecting foamer or like a surfactant down the cap tubing to help actually artificially lift the well. So operator will inject cap tubing into like a dry gas well and be able to produce that well via foamer injection.
Right.
So pretty wide variety. And I think, in my opinion, it kind of varies based off of basin and what your ultimate goal is from a production standpoint.
Oh yeah, each oil field is different.
Mm-hmm.
Each oil field is different.
Yeah, definitely. So those are kind of the applications that we see, and we'll talk a lot more about, if it's CO2 injection, if it's chemical injection, or if it's foamer injection based off of the well type. But the idea is to either provide artificial lift to the well that may be different from like ESP or rod pump or gas lift or plunge lift, right?
Right.
If they're using it for chemical injection, hopefully that chemical is like protecting the tubing, right? Maybe it's keeping it from bridging off with salt.
Right, which is mostly what you see, in the Permian.
Yeah, and I know in the Bakken we see a lot of freshwater injection just to prevent salt buildup.
Right.
And then of course, the big one is maybe we need to get chemical down to like an ESP or sucker rod pump, right?
Right.
And so that chemical's treating the pump along with the production tubing side. So yeah, those are kind of the things we see. Let's go through and really look at each one of them and why we see those applications. And so, like you mentioned, Keith, a lot of corrosion and paraffin control, right?
Right.
So they're injecting the chemical down the cap tubing. Where do they typically set that into the cap tubing?
Usually just right above your packer.
Okay.
And that's if there's a packer in the hole. If not, if there's no packer, then usually right at the end of tubing.
Okay, or like above the pump.
A joint above or above the pump.
Okay. Okay, perfect. Yeah. And like I know in the Bakken, we have a lot of salt and scale control. So like we see a lot of freshwater injections where they're injecting freshwater down the cap tubing just to help dilute that chloride ppm and keep those salt bridges from building up.
Yeah. And that's usually 1/2 inch on those two.
Okay, bigger cap tubing in those. Is that just because of the volumes that they're pumping?
Correct.
Okay.
Volume.
So bigger cap tube and more volume you can get through it. Okay. And I think we have a slide that shows some of those different selection guides, right?
Right.
Yeah. Okay. And then, another interesting thing that we've started to see more in gas fields is actually injecting like a foamer or, a surface tension change or modifier for gas wells.
Right. Which I'm very surprised, like the Eagle Ford area doesn't do a whole lot of that,
Yeah, you tend to see that more like Haynesville or Marcellus up in those dry gas fields. But that's been pretty interesting because an operator, a lot of times might install a cap tubing just inside casing without any kind of production tubing and inject that foamer to help keep those wells on production. So pretty neat little applications.
Oh, yeah.
And, I guess in my simple brain, it's basically just small tubing.
That's
so
it.
whatever you can do with tubing, you can do with cap tubing, right?
Right.
So perfect. Well, and as we kind of talk about it, my big question is how do you get the cap tubing in the well?
So you got 2 different scenarios.
Okay,
right?
2 different deployment options.
Correct.
Okay.
So the one on the left you see
over
is
here
an external.
Okay.
Right? And typically it's tied into a mandrel.
Yep, and we got a slide that shows that, that's going to anchor it at the bottom of the tubing.
Correct, slightly above the packer.
Okay.
On this one. And then the other one, the internal, is obviously that's internal, and that's just either above the packer. Some people will go like 10 feet out of the packer.
Okay, like out of the end of tubing.
Right, out of the end of tubing. And but for the most part, those are just your two ways of doing it.
Okay, interesting. And so with like your external, you run that cap tubing with the production tubing.
Correct.
So how do you typically attach that to
So
the
usually
outside of
you'll
the
run
tubing?
some clamps depending on the deviation of the well, right? If it's over 10 degrees is the rule of thumb.
Okay.
If it's
So
over
you're
10
looking at
degrees,
the inclination of the well
correct.
to decide that.
Right. So if it's over 10 degrees, definitely run clamps.
Okay. And those clamps are there, what, just to protect that cap tubing?
So the clamps go across your collar,
Okay.
right?
Yep. Which
And
is going to be your biggest OD of your
Right.
tubing.
So you got to protect that.
Yeah.
You don't want to pinch off your
Because
tube.
you don't want that tubing banging against the ID of the
Mhm.
casing, crushing that or cap tubing.
Right.
Okay. Okay. And then internally, so that can just be deployed like down the inside of the tubing or
Right.
casing, right?
And the
If it doesn't
beautiful
have any tubing.
Right. And the beautiful thing of internal is, well, you have no rig. You can come in anytime you want to do it.
So you can pull that independent of a workover rig. Whereas like with your external, you have to have a rig to run it and you have to have a rig to pull it.
And sometimes if things happen, right, with the string got pinched or something of that of that nature, typically they'll come back and run an internal string as well. So that way
you're saying if like your external cap tubing gets compromised, plugged, damaged.
Sometimes that does happen.
You can run a internal on a system that already has external string to continue.
Just to continue. That way you don't have to get a rig.
Okay. Interesting. Yeah. And so we'll get into
that's very expensive, right?
Right.
So
yeah, and you'd hate to have to pull tubing just because your cap tubing plugged. Yeah. No, that's a good point. And so we'll get into the applications, like how you get that equipment in the ground.
We'll see one here in a minute.
Yeah, definitely. And so typically when you're seeing this, what's usually the size of cap tubing?
So in the Permian, pretty much everybody uses 1/4 inch.
Okay, 1/4 inch, and that's the OD of the cap tubing?
That's the OD.
Okay. It's pretty small.
Oh, yeah.
Oh, perfect. Well, yeah, and when we talk about like deployment, right? So you mentioned external and internal as like your two deployment options.
Right.
What are we looking at?
So right here, this is an internal unit.
Okay, this truck and cab.
Yep.
Okay.
And the cab is where the operator sits.
Oh, looks like it's air conditioned.
Yeah, he's pretty lucky that way.
Man, no kidding. Are they all air conditioned?
No.
Oh,
just those.
Man, I'd hate to be working in one of those things during summer.
Yeah, especially right now.
Right.
So typically they have air conditioning.
Okay.
And
they have a refrigerator in there?
Some of them.
Some of them. I know working on E-line trucks, a lot of times they would have a refrigerator in there.
Right. So from here you got the operator that sits in the unit. He's watching his weight. That's the big thing, right? Just like wireline, almost the same. He's watching his weight while going in hole. So you got your operator. You got a spool.
Okay, that's this piece here.
That's your spool there.
Yep.
Then you have a counter.
And that's just like your slick line or E-line counter.
Right.
Keeping track of your footage.
Yeah, just keeping track of how much you're going in hole. And then from there it goes into an injector head, which is on the top there.
Okay.
And then shoots straight down into the well.
And so that injector head essentially force feeds that cap tubing down the inside.
Yes, and it's dependent, right? Because it also depends on pressure, so I mean it's gravity but forced.
Okay. Now, and I guess that's a question I always have, is very similar to a snubbing unit. Once you get pipe heavy, will it just essentially gravity feed in?
Correct.
Okay.
Correct. Yeah, and that's the basic concept, is that it's actually a miniaturized coil unit. That's exactly what it is.
Yeah, it looks just like a coil tubing feeder. And then that's just pushing it down the inside of the tubing.
That's it.
Very neat. Okay, and so this is that internal deployment.
Another thing to keep in mind too is that the operator that's in the cab, he's monitoring the entire time. He's checking his pump, making sure that nothing's pressuring up, nothing of that happens, right? Because things can happen.
Yeah, and I think we have a few slides coming up that show like what that panel.
And that's typically a 2-man operation. That's typically you have to have a spotter on the ground and then your operator.
So both guys don't get to hang out naked.
No.
Oh man. Okay.
Only the operator's nice.
Only the operator. Nice. All right. And so that's internal, right? That's how we deploy it, either down the inside of the tubing, or if the well doesn't have tubing, deploy it down the inside of the casing, right?
Right.
But if we're talking external installation, is that what we're looking at here?
Yes, that's correct. So typically on that, well, on this one specific, this is this is a fancier unit, right? This runs 2 strings.
Okay, yeah, because we have one spool here and one spool here.
Right. So if you wanted to run, cap and gauge, instead of having 2 units, you got one that can do both.
Oh, okay. So you could have like tech cable on one for downhole gauge,
right,
and then cap tubing on the other.
Correct.
All right.
And so you got your guy here on the ground, and we'll go into another slide, but you got a guy on the ground that's monitoring your gauge, monitoring your pressure on your CT line. You got another guy on the floor that's banding the entire way or clamping.
And that's what we talk about, attaching that cable to the outside of the tubing.
Right, that's correct.
Okay. Yeah, and let's look at this next one. I think this one kind of dives in a little more.
Correct. So this one right here will show that you can see the control panel, right?
Right here.
Yep. So he's monitoring pressure as they're running in hole.
And when you say pressure, that's pump pressure on the cap tubing?
On the cap tubing.
Okay.
Yeah, so it's a very good rule to, as soon as you tie in your string into your check valve, pressure up on your check valve, make sure that your check valve is flowing, right? There's no problems.
Right.
And then after that point, you then run in hole.
Okay.
And so he's watching that while the other guy's on the floor.
I see.
2-man operation.
And so while that guy's sitting here watching that, if it like pressures up to a higher pressure than it should.
Right. Usually 500 pounds.
Okay.
500 pounds, 1,000 pounds, depending on what your check valve set at, right? Typically your check valve can be set at a certain pressure.
Okay, and I got a slide for that. And so if you see that pressure up, that usually means
then you know there's something wrong.
Pinked the
and the big thing is the guy that's on the floor, he's also watching, making sure that your string is not getting pinched or anything.
Like from the slips or something like that.
Yeah.
Okay.
So I mean, and that happens, right? So it's you got 2 guys that, one backing up the other.
I see. So one guy's here and then the other guy's up on the rig floor.
Correct.
And he's helping the rig crew
making sure that
take that cap tube and attach it to the outside.
Well, and he's making sure that everything's centered, right? Because that's really important. Making sure that your tubing's centered, that way your string doesn't get pinched. And then from there, running hole. So.
Okay. And then with this one, that spool's not like pushing anything, right? The tubing's physically pulling the cap tube.
You'll typically have back pressure
just to keep it
back
tension.
I'm sorry, back tension on the spool. And that's another thing to keep in mind too, because you really want a banding trailer to do a banding job, right? Because you want to hold back tension the entire time. So that way, if you have a pedal that's on the floor, typically they'll run too much, and if they run too much, then you'll have a big wind or big extra, if you will, on the tubing, and then you can have some problems, going in hole.
Yeah, that makes sense. I mean, it's almost like a bait caster, right?
Right.
Everybody likes to fish.
Right.
You want to keep that tension on there so it keeps that spool tight.
Right.
And it keeps it tight to the tubing as well.
Correct.
Interesting.
And then on that one, another thing I like to point out too is that that's a 100-gallon tank.
This piece.
So he's not going to run out of water.
Okay. Yeah, and that's one question that I get a lot, and we'll look at it here in a few slides, is how much, what's the capacity of cap tubing? Because like when I think about
typically
production
30 gallons is the best rule in the Permian.
Okay.
It's 30 gallons. As long as he pumps at least 30 gallons, he's going to flush pretty much any string.
Okay.
How many feet is that?
Usually right around 10,000, I believe. 10,000.
Perfect. Yeah.
Which is going to cover most of your Permian wells, right? But that's just a general rule.
Good.
My guys do.
Okay. Yeah, that's good, because usually like when you look at production tubing, we're talking like barrels, capacity.
Yes.
And here you're talking
gallons.
Yeah. That's good. And usually what do you put in that tank? Is that just
deionized water? Deionized water. Yes, you need to have deionized water, because if you have regular water, it could react to your chemical, which can cause a plug.
Gotcha. Okay. Yeah, and we'll talk a lot about the chemical.
Yeah, and that can happen.
Yeah. Okay. And then I guess up in the northern states, a lot of times they'll use like methanol, right?
Right.
Instead of water, in place of water, right?
Correct.
Okay. Very neat. Yeah, that's cool. And so that's to help us really get the equipment down hole, or the cap tubing, I should say. One of the other things I like to talk about is, what things are we attaching to the cap tubing? Are we just running the cap tubing open-ended?
No, that's a big no-no, because if you don't run a check valve,
which is
which is
this
that on the
piece
left
right
there.
here,
Yeah,
right?
you don't run a check valve. You just have basically pipe open,
Mhm.
which 2 3/8, 2 7/8, you can kind of get away with. 1/4 inch, you can't.
Doesn't take much to plug it
Doesn't
up.
take much to plug it up.
Okay.
You're 1/4 inch OD, so it's not very big.
And so this chemical injection valve, that attaches to the bottom of the cap tubing.
Correct, which then ties into a mandrel or a carrier.
Which is this piece here.
Correct.
And so this is going to be run for external installs to anchor that cap tubing right at the end of the tubing, right above the pump.
That is correct.
Okay. Now, I always had a question on this. So this is tied in the tubing. Here's the top box connection, the production tubing is. Here's the pin, lower connection. What happens if I want to inject my chemical into the tubing casing annulus for, say, like a sucker rod pump or an ESP application?
So typically you'll have holes right there in your lug.
Right here?
Yep, that's correct.
Okay.
And then they'll seal off your tubing side.
So it still acts as an anchor,
Right.
but rather than directing the chemical inside of the tubing, it's pushing that chemical to the tubing casing annulus.
Right.
Okay. And then
which you got to be careful with too, because you got to check with your chemical guys, making sure that they're putting the correct chemical to the string, right, or to the L80 lug that's there. So that way
you're
don't
talking
corrode.
about this material here.
Yeah, you don't want to corrode that out, because then if you corrode that out, now you're loose.
Gotcha. So you're saying sometimes the chemical can actually be corrosive
that can happen
to the tubulars downhole?
Right. We've seen that. That's happened before.
And in a case like that, then you'd want to change your material, maybe go to like a stainless steel or a 13 chrome.
Right.
Okay.
Yeah.
So, and I know we'll talk about the cap tubing material selection,
right.
but that's a good point, is just like matching your cap tubing to the chemical, you're saying you want to match your
lug,
your mandrel material
yeah,
too.
Definitely watch your lug.
Okay, good. And Keith, a little bit on this chemical injection valve. So this one looks like it has a one-way flow check and a pressure regulator.
Correct. So yeah, it's spring loaded up top. Yeah. They can typically set that to usually between 500 and 2,500, maybe 3,500 pounds. PSI.
Okay.
And then, and so it acts as a secondary, if you will.
I see.
And then, of course, we'll talk about surface, but you have another one on surface as well.
And that 25 to 3,500 PSI, is that downhole pressure or surface pressure?
That's going to be downhole.
Okay. And the idea behind having that pressure regulator
is keeping your string full, because you don't want it to just dump.
Right, because if you stack fluid in your tubing, you could have 4,000 or 5,000 PSI of hydrostatic, right? And if that's greater than your reservoir pressure, you're just going to gravity feed your fluid out of your cap tubing. And so that pressure regulator, chemical injection valve, is there to essentially artificially hold back fluid in the tubing.
That's right.
Okay.
Which again, we'll talk about the next thing that can help you out too.
Up at surface. Now, sometimes I see operators just run a check valve instead of the chemical injection valve.
You can do that. The issue is that you're taking that risk, right, of just dumping each time.
Gotcha. Okay, so this is
typically
more like
you see that more in your CO2, that kind of stuff.
I gotcha. Okay. Interesting. And so this is more of like a controlled pressure regulation of that chemical.
Right.
All right. And then this is run internally or externally, right? You're running this on everything.
That's right.
Okay. And then this mandrel is just run for external to anchor it at the bottom. Okay. And so we
this is going to the clamps that we were talking about. So this is what's going to protect. You can see a collar there. So that will protect your cap string from your casing.
Okay, so this is attaching to basically two joints of tubing. Here's our collar, so it attaches above and below.
Right.
And then the cap tubing's running down in this channel right here.
Correct.
Okay.
Yep.
And that's so if your collar hits your ID or your casing, and your cap tubing happens to be there, it's not pinching it or crushing it.
Right. And
Okay.
you can see on each side of that clamp, they're beveled too, down to make sure, you don't hit anything. It has a slight bevel right
here
there.
and here. Okay. How often do you see operators running these clamps?
Man, it's actually become more and more now. That seems to be, a thing now. Especially, and some people don't even want to take the risk, so they just run it from bottom to top.
Run clamps. So
Right,
every
run
time they
clamp.
make a joint connection, they're running a clamp.
Yep.
Okay. Because what's the other way to attach your cap tubing
Is
besides a clamp?
Well, and that's bands, right?
Okay.
So, I mean, bands are good, but clamps are just way better, right?
Because with the bands, they could either be erosionally broken or mechanically broken if they hit the casing.
That is common, that does happen. That's the reason why we go that 10-degree rule,
For clamp.
for clamps.
So you're saying if you see 10 degrees of inclination or greater,
Right.
you want to run clamps
Correct.
across that section?
That's correct.
Okay.
Well, and remember, it's not just across the section, it's from that point down. Because everything's got to run through that.
Gotcha. Okay. So, sometimes on these multi-well pads, we might have like an early or shallow kickoff at say 3,000 or 4,000 feet.
Yep.
And then it's going to run at an angle for a while and then kick off to the horizontal section. So you're saying across that piece, you're going to run clamps.
That's correct.
Okay. That's good to know. And then I know there's a bunch of different clamp styles out there.
Right. Yeah, and that's very important. Think of too, your ODs or your clamps. Sometimes you're limited on OD. That's another thing to think about.
Yeah, because you're
Especially once you get into like the Eagle Ford area, 26-pound casing, that kind of stuff. You're limited on the type of clamp and the OD of the string that you're running in hole.
That makes sense because you're putting, so you have your collar OD plus the diameter of the cap tubing
And
plus
clamp.
this extra material here. So between the wall of the collar here and the wall of your clamp here, you could increase that OD to where it's bigger than your ID of your casing.
Right.
Okay. And I know like the Holt guys have some really cool clamp designs. And I think there's a bunch of other.
Yeah, they're cast. Those are typically cast, and they do take a little longer to install, right? Usually, this is fine too. This is a Canon style in the picture here.
This style here.
Right.
Okay.
Which is just it's fingers and then a pin driving through the finger.
That's the pin right there.
That's it.
Okay. Yeah, very neat. And so I like the 10-degree rule. But if an operator wants to just be super safe, you can do clamps top to bottom.
Oh yeah, that's no problem.
Okay. Perfect. And that's either in combination with bands or in lieu of bands, right?
Right.
Okay. All right, perfect. So that again, this piece, just like the mandrel, that's for external installs,
That's
right? We talked about internal installs, getting the tubing inside the production tubing. And actually, hold on, I got a question for you, Keith. So relevant question for what we're talking about here. So we're talking about external. I want to stick to the external conversation here, where you want to run a external cap tubing string, but you want to treat for annular flow gas lift. So I guess, does that maybe jump back a slide to here?
Right. Which is what we've been seeing too in the Permian. That's been a spike.
Okay, so you're saying the operator's running externally banded cap tubing for annular flow gas lift? Okay. And then with that, is that what you were talking about?
The holes there.
Okay, and it's ported to that annular. Okay. Any risk associated with doing that type of application?
I wouldn't say. I mean, as long as you're treating, you're fine.
Okay. And I guess the only other thing would be your cap tubing's exposed to your produced fluids.
Right. But I don't think that's so much the issue. I think more of the issue is just always protecting your casing, right? So.
Okay. Oh, good. Yeah, that was a great question. Thank you, guys. So talked about that. Now kind of shifting gears, going back to internal.
Okay, so here you got two pack-offs, two different types of pack-offs, I should say. You got a threaded, then you got a flange, right? And this one's a dual pack-off. which basically, I mean, it's exactly what it is. It's a back off. So you'll run your cap string through the top,
Up
and
here?
this stabs straight onto your wellhead.
So this flanges into your
flanges-
crown valve.
That's correct.
Okay.
And you can work just straight off of your crown valve on this one. That specific one there, it's got 30 inches from your bottom of your rubber to your flange, and of course a couple inches to your crown valve. So that way you can make up BHA, all that good stuff, have it in hole, and then open up your crown valve and shoot it down hole.
Okay, so this is going to be attached to the top of the wellhead.
Right.
You're typically matching this to the same pressure ratings as the wellhead.
Right.
Okay. So if you have like a 10K wellhead, you're going to want to put a 10K
Correct.
hanger on there too.
Right.
And then the cap tubing is deployed down the center of this through the wellhead.
That's right.
Okay. So I got a question for you on this. If you're running the cap tubing down through your wellhead and across your master valves, what happens if somebody shuts a master valve?
I was hoping you would say that.
Well, I get that question a
That
lot.
does happen, no matter how many signs you put on or chains you put on. It does happen. Sometimes, some guys will close it, and then next thing you know, you lose your string.
So the master valve will cut the
It will cut it.
cap
It
tubing.
will cut it. Yes, it will.
And then what do you do once
From
it's
that
cut?
point, you fish.
Okay.
Which typically your internal unit, they should have fishing tools. If they don't, you need to get braided line to come out, fish your string out of hole.
Okay, so you can use that internal unit that we showed earlier
Oh yeah,
to
definitely.
pull it out, because that cap tubing is just sitting down on the inside of the tubing, right?
Yeah, typically those the drive, or sorry, the head on an internal unit is, they usually can pull roughly around 8 to 10,000 pounds.
Oh, wow.
So I mean, that's a lot more than what your 1/4 inch and your 3/8 is rated to.
Okay. And then you said braided line.
Braided
to come
line
in and
is
fish as
usually
well.
the kind of the go-to,
Mhm.
just because they do carry several different types of fishing tools. So yeah, that is normal. That does happen from time to time. And I shouldn't say normal, but it does happen,
Mhm.
right?
Okay, well, and that's good to know, because I mean, sometimes if you have like a blowout condition or well control,
Right.
you may need to shut that master valve
Yeah.
to close that well.
Well, and a lot of times too, they won't fall very far. If you have to, like an emergency situation, right? You have to go cut the line, cut it. Usually it falls maybe 50 feet, something like that. Because you got to remember that string has got memory in it, right? So it's going to sit there and try to cool inside of your tubing. So usually you can just reach right in, grab it with your unit, and then pull it right out.
Okay.
Some I've seen, they'll reach in, grab it, and then just set it right back.
Really,
there.
just hang it back in there?
Yeah,
leave it?
we'll pump
Okay.
through it, make sure that it's good, and if it works, it's
Nice.
fine. Mhm.
What fishing tool is preferred to catch cap string?
Usually an overshot. Usually use an overshot.
Okay, so that's a slick line or braided line overshot.
Right,
Okay.
right. Yeah, and then the next thing would be like a I don't even know the name of it, but it's basically a rod with a bunch of, you
Like
know,
a spear.
like a spear.
Yeah.
Basically, it's just a spear.
And then, is it recommended to run a bull plug at end of tubing with perf subs?
I
good
always
question.
try to recommend that, so that way you wouldn't have to run a no-go on bottom. And unfortunately, I know we don't have that slide, but sometimes they'll run a no-go to go set right in your X nipple or XN nipple, and that way it doesn't go past, that point, right? The only problem with a no-go is that your OD of your no-go is close to the ID of your tubing, right? So you don't want to have any issues when you're going in hole internally. So running a bull plug with perf sub, man, that was great.
Yeah, that's good, because that way it just keeps that cap tubing from falling out
Right,
the
and
bottom
then
of
you
the
don't have to
tubing.
worry about a no-go. You don't have issues of going in hole with
Yeah.
internal, any of those.
Interesting. Yeah, that's good to hear. Good question. Thanks, Robert. So we talked about how we get the cap tubing downhole, right?
Right now.
What we put on the bottom of the cap tubing, and we started with the surface, at least from a internal side.
Right.
So what do we, once we get the cap tubing up to the wellhead, what do we do with it then?
So then it's then ported through a hanger, which we have a slide here in a minute. It's then ported through a hanger, through your tree, and then you have a manifold.
Okay.
This is the key.
This is a manifold here.
That's the manifold.
Okay.
That's the key to the whole operation, I would say. On this one specifically, you got a filter,
which is this piece
which is
here.
that piece
Okay.
here, which that one's a really good filter. It's got a longer bowl in it with a longer filter as well.
Yeah.
Then you got an ASV right there, which is an anti-siphoning valve.
ASV is the anti-siphoning valve.
Right, which holds back pressure as well on your string.
So if your, say your check valve fails or bottom hole pressure
That's
drops,
that's another way to watch it.
okay, because that's going to keep the chemical from just siphoning down.
Mhm.
Okay. And that's this piece here.
That's it.
And you recommend putting that on every well?
On every well.
Okay.
And that one specifically, you have a check valve in it as well, with the anti-siphoning valve. So it's kind of a dual purpose as well.
Oh, nice. And that's just this little device here.
That's it.
Okay. And then you have your gauge, I imagine, so you can monitor surface pump pressure.
Correct.
Okay. And this manifold gets put on every cap tube, right?
Every one of them.
Okay.
You have to. And it's very important to keep in mind, again, I know I pointed out the filter being longer. It's very important to point that out, that you have a good filter, because you got to remember, this is what's going in your well. It's got to pass through that filter. And sometimes, if a guy may forget to go and clean the filter, that longer filter will keep more debris in it, I guess, if you will, until somebody, I guess, remembers.
Yeah. And this might be a dumb question, but how do you get debris in the fluid that you're pumping?
Well, and that's what we're going to get to here in a little bit. But typically that happens whenever, filling up totes, filling up those kind of things.
Okay, so when the chemical company's filling the tank up.
Right, they'll stir up any of that stuff from the bottom. If they let it go too far, usually that ball valve off of that tank is 2 inches high for a reason. Usually it's going to let some of those bigger chunks stay on bottom.
Yeah.
And then whatever else after that should go into your cap string. And then your cap string, your filter should capture that, right?
Because you don't want those solids going into the cap tube.
Yeah, because again, it's 1/4 inch, so it doesn't take much. And again, I'm talking from a Permian basis. Right?
Yeah. But I guess really any of those strings are pretty small.
Oh yeah.
So you want to try to keep any kind of solid.
Yeah, there's not much forgiveness.
Yeah,
I would say.
I can imagine. Okay, perfect. So that's the manifold, and we have a couple examples of that manifold, like on a wellhead, right?
Right. Yeah, and that's a picture here on the left. That's just a normal cap string going to hole. The one on the right has been really popular out in the Permian as well, is with ESP. You can see the ESP cable going in there. And
right here?
Yep, right there.
Okay, so this is a capillary tubing string installed with an ESP?
Right.
Okay, and both of them are going to be external?
Right, that's correct.
Okay, and so why would an operator run cap tubing?
Because you want to treat that area for sure. You want to treat all of it. Sometimes they'll run them above. They'll tie it in right into the intake. So typically the
intake of the ESP.
The intake of the ESP. But they'll run the check valve usually right on the first joint. So they'll splice in your check valve. Going in hole.
Okay. And then that way the intake of the ESP is basically sucking that chemical in and treating the pump along with the production tubing.
That's right.
Okay. Interesting. Yeah, you can see that ESP surface connection there. Very neat. And then there's your manifold. And I guess your chemical is tied in over here.
Correct.
Okay. Perfect. Well, and the next thing is, so we got the surface. How do we get it through the hanger, right?
Yeah, the hanger part is the most important part. And I like to, point out too, a good rule of thumb on this is that if you're running 1/4 inch line, always go a size bigger on your port.
So you're talking about the ID of this borehole through the hanger?
Right, because typically, I've seen that if you're running 1/4 inch string, people think you can run a 1/4 inch, run a 1/4 inch bore through your hanger, but you're quarter, so it's
be pretty tight.
It's a little tight. So usually, what I like to recommend is that if we're going to run 1/4 inch string, run a 3/8 bore. Or if you're running 3/8 string, run a 1/2 inch bore.
Okay, right through here, and it just makes it easier to pass that.
Yes, because right, time is money, right? So if you're sitting there trying to push this string through that hanger, you're gonna waste a lot of time.
That makes sense. So different than your production tubing, you're actually passing that cap tubing through the hanger.
Right.
You're not just cutting it and hanging it off the bottom, just like you would with your production tubing.
No, you're not doing that.
So the cap tubing's continuously pushed through and then comes out the
usually about
the wellhead.
Foot, 2 feet out.
Okay, that's good to know. So if you're doing 1/4, get the wellhead hanger company cut a 3/8.
Yep.
Could you do 1/2? Is that okay?
Yeah, you can. Yeah, the bigger the better, right?
So if you standardize on a 1/2 inch borehole in your hanger,
then you should be
you cover everything.
Yeah, and I've seen that too out in the Permian, that most people will run a 1/2 inch bore, so that way you can and typically on our installs, you'll run 2 1/2 inch bores, cap and gauge.
I see.
Right. So that way you're covered either which way.
Okay. That's good to know. Yeah. And that's something that the wellhead company can put together for you.
And then another thing I'd like to say on the hanger on the right.
This one over here?
Yeah, I don't recommend that hanger. I know sometimes you have to run that hanger, but you're coiling that cap string around the tubing.
You're talking about up here.
Right. Yeah. And wrapping it, you're taking the chance of risking of breaking your cap string.
Okay, so you don't recommend this. You recommend just a direct pass through. Okay, that's good to know. And I'm sure everybody would hate to have to sit there and wrap that stuff.
Man, I don't.
Yeah. Well, that's good to know. Okay. Well, man, thanks, Keith. So we talked about cap tubing. One of the things we've talked a little bit about size, right?
Right.
But the most common sizes you see, right, are going to be 1/4, 3/8, or 1/2 inch.
Right.
And typically that bigger size, like 1/2 inch, that's going to be more for like a freshwater treatment or a CO2 injection.
Right. Yeah, and I mean, you don't really. And as far as the Permian, usually 1/4, 3/8, that's what's most common.
Okay. And that's going to be for chemical injection.
That's going to be for chemical injection.
And then, so you have size, we typically have materials, right?
Right.
So we got 625 Inconel, 825 Inconel, and 2205, essentially like a duplex stainless, right?
Right.
Yeah. And so out of these materials, I'm guessing this is going to be most common. And then these are going to be more for your corrosive high temps environment.
Right.
Okay. Perfect. One thing, I know this is just a little chart, but one thing I wanted to point out, you talked about the capacity. Here's our capacity over here.
Yeah.
And it's a little different.
Extremely different.
Yeah. So that's gallons per 1,000 feet, right? So if you're dealing with like maybe 1/4 inch, it's what, 1 gallon per 1,000 feet?
It's not much.
Yeah, it's not very much. And if you're dealing with 3/8, it's 3 gallons per 1,000 feet, which is crazy because we're used to talking barrels per barrels per foot, right, on production tubing. So it's pretty small.
Another thing to keep in mind too, I know we show pressure there.
Down here.
Remember, just because the pressure rating is very high on your tubing,
it's really high.
You're actually limited on your fittings. That's another thing to keep in mind, which is usually right around 10,000 pounds on fittings. So if your 1/4 inch cap string is rated to 30,000, that doesn't mean you can pump 30,000 pounds of pressure.
Right.
You
need to limit it to
your fitting.
Okay, that's good to know. So you mentioned 1/4, 3/8 is your common sizes. 2205 is like your most common material.
Right.
But these are some of the things that are going to affect your material selection, right? Temperature, reservoir temperature, your chlorides of your water.
Right.
And then your pH. So I'll jump ahead to this that kind of helps with that material selection guide, right? And so I imagine Permian Delaware typically plays over here in
Oh
that
yeah, right in the
range.
2205.
Yeah,
range.
and that's why you see it the most.
Mhm.
And I know in like Haynesville and Bakken, we usually have a little higher ppm
Right.
of our chlorides, and of course our temperatures are usually a lot higher. So we see a lot of 825 alloys being run.
Right. That's correct.
Yeah. And then one other thing I always question about the material selection, say for like an internal where you know you're going to be running that tubing multiple times,
Yep.
is it a good idea maybe to go up in material so it lasts longer?
Yeah, I would typically, so that way that's one less worry you have to worry about, right? Go ahead, get the 825 material, run it internally, and then if you want to pull the string, you can pull it, run it on another one.
And you
run it
know
on
it's gonna
and
last.
you know it's gonna last
Okay.
several times.
Yeah, that's good to know. So if you
What
have
happens a lot. I mean, that's really normal.
okay, so if you have operations where you know you're going to do multiple runs
Right.
of one spool of cap tubing,
Right.
you can always go up to like a 825 alloy,
Right.
and you're just cutting out that corrosional aspect of
Right.
it.
Well, and then that way, if you know you're gonna pull it and put in another well, just it's best just to go ahead and get it. That
Mhm.
way later you don't have to get another string.
I see. Okay, because you can rerun these strings multiple
Oh yeah,
times,
multiple
right?
times.
Okay, very neat. Yeah. So,
And you can weld them. You
oh
can weld
really?
strings. You can weld strings.
So if you have a damaged
If
section
you got
or
a damaged
broken,
section, you can cut it out, weld it back together, run it in over.
what happens if you have two spare short strings and you want to make a long string?
You can do that too. You
Really?
can weld 'em.
So you can weld just the two pieces of cap tubing together.
Oh yeah.
What's the tensile rating on that?
The same as the tubing.
Is it really?
Oh yeah.
Wow. And you guys test that?
Oh yeah.
Make sure.
Oh yeah.
Oh, that's good to know. So operators could essentially reuse old or pulled strings.
Yeah, several times.
Okay. That's good to know.
Yeah,
Okay,
I
more
think
than
I've
the
seen,
production
I think
do
I've seen strings that were done 10, 15 years ago that are still pulling and rerunning.
No
pulling,
kidding.
Oh yeah.
Oh, that's nice. So like from a upfront capital expense, they
Mhm.
might have it there, but then after that, it's just reusing the same
Right,
stuff.
right.
Okay, man, I learned something new today. So Keith, we're running short on time, but a few things I want to touch on before we wrap up today.
Right.
We've talked about how you get the tubing in the ground, how you pick your tubing types, but now I really want to talk about a piece that I kind of feel like
This
gets
is what,
forgotten.
this is exactly, that's what gets forgotten a lot. Typically, we like to advise, every quarter, if not twice a year.
Okay.
At least twice a year. Just flushing your string, making sure your string is, clean of any debris. Typically they'll flush it with deionized water, and then you can always fill it back with your chemical.
And so you're talking about maintaining that cap
Maintaining.
tubing once it's down hole, right? And your big fear with cap tubing, is it plugging up?
Yep.
Okay.
Yep. And then, and that typically happens again, going back to the tank. That usually if anything's going to happen, it's going to come from that tank. And so making sure your lids are on.
Especially out in West Texas.
In West
right?
Texas, we love wind out there.
Yeah, and it's dusty.
And
out
there's
there.
nothing to cut it, right?
Yeah.
So making sure lids are on, making sure that, that we're always keeping the tanks, somewhat full. Because when we fill them, again, that
You
debris,
stir everything
you stir
up.
everything up. And again, usually plug strings, they happen right after somebody just pumped or just filled up the tank with
Oh, really?
chemical. Oh yeah.
Okay.
That's very typical.
Yeah. And so say we have an external string installed and you're talking about doing some kind of maintenance program, typically quarterly or twice a year.
Right.
So do you have to come out there and pull tubing and the cap tubing out?
No. Usually it's just what we call a pump trailer.
Okay.
Pump trailer comes out, ties in a hose straight into the manifold and pumps right down the hole.
I see. And so you're just basically flushing
The
or
string.
displacing the chemical with water.
Right.
And then once you're done, you refill it with
your chemical.
the chemical.
Mhm.
Okay. And then for internal install, is it similar?
It's the same thing.
Okay.
Same exact thing. Same concept.
So any operator that has cap tubing
Yeah,
should be doing some kind of plan to it.
Yeah, I would definitely recommend that. That's
Okay.
that's a big one because a lot of times after you install it, typically that part is forgotten.
Oh yeah, I
you
can
know.
believe that. Yeah, move on to the next
Yeah,
one,
just
right?
move on to the next well. So, maintaining it after that point. So that way you don't have to pull it, right?
Yeah.
Because it's expensive to pull.
Yeah, does that make sense? Because if you plug it, then you've lost that application, and then at that point, I guess if you have a really corrosive or salty well, then you just have to wait for it to fail.
Right.
Yeah. Okay. And so, want to talk about like why stuff would plug up. One, it's pretty small. But sand, dust is kind of a big one.
Yeah, filters, not catching what they're, supposed to be catching. 25 micron, that's definitely a good filter to keep
Okay.
in mind.
Yeah. Another thing too that we see more in the high temp areas like Haynesville and Bakken and Eagleford, it tends to be like incompatible chemicals with the cap tubing.
Yes, that can happen where it reacts, to the deionized water or to something downhole or air. We've even had that.
Okay.
Where it reacts to something and then plugs it off. So you got to watch those things. It's very important to be very, communicate with your chemical guys, making sure that they're putting the right chemical to the right cap string to the right lug. Right.
So you want like a cap tubing compliant chemical.
Right.
Okay.
Right. For sure.
And I've noticed temperature can have an effect on that too, where you almost like dehydrate the chemical out inside the cap tubing.
Yeah. If it's not, if your pressure's not set right on your check valve and it's not doing what it's supposed to be doing, then it can just essentially sit there and dehydrate, and then now you got to plug.
Now you got to plug. Okay. So say you get a plug in the string, can you sometimes pump through that?
You can pump through it. Most of the time, the same pump trailer that comes out, it can tie straight in, pump usually up to 8,000 pounds. Try to flush it out, as much as it can. That's your best bet before, pulling a string or pulling anything, right?
Right. Okay.
So it's definitely a good last try, if you will.
Yeah, that makes sense. And so Keith, man, that was it.
Yeah.
I got some questions for you, so don't run away just yet. But before we wrap up, just wanted to touch on, this continuation of the series. So we still have a few more for the year. Next month, we're going to talk about downhole gauges from a reservoir monitoring standpoint. Yeah, so that should be good. I'm excited about that one. And then, of course, we'll continue to talk about some of the plunger lift applications, 102 plunger assisted gas lift. So with that, let me stop sharing, Keith, so we can put you in the hot seat and ask you some questions. So, guys, thanks for getting on. Of course, we're going to have this thing recorded while we have Keith here. Want to kind of ask him a few questions related to cap tubing and his experience out there. So one of the questions I had, and I think you've answered it, but I'm asking you anyways, is like what, from one application to the next, what's the common cap tubing size? So let's say we want to do chemical injection treatments.
Right.
What's the typical size that you see?
So usually quarter
inch.
That's pretty normal.
Okay. And then if I were going to do like a CO2 injection,
you would go half inch.
Half inch
or greater.
And that's just so you get more volume down.
Right. But keep in mind, you are limited on depth, because of your head, right? Obviously on your internal unit.
Okay.
So, if you're going to run 3/4 inch line, something of that size, you may be able to only go 5,000-6,000 feet.
I see. Okay. Because the half inch just weighs more, right?
Right.
Okay. Perfect. Another question I had is, along the lines of capillary tubing for chemical injection, what's the most common artificial lift system that you see cap tubing run on?
Typically gas lift. That's pretty normal.
Oh, really?
Yeah, gas lift's pretty normal, but ESP has been picking up quite a bit. But gas lift is almost every job.
Really? And then that way you're treating basically at the end of the tubing string and not relying on your injection gas to deliver the chemical.
Well, and a lot of people too, they've run gas lift and go annular flow. That's been very common now.
And so you're running capillary tubing with an annular flow gas lift to treat the tubing and the idea of the casing.
Correct.
Okay. Okay, interesting. And then I got two more. This is more of a personal preference question. When you're running externally, do you prefer bands or clamps?
I'm a clamp guy.
Clamp guy.
Oh, yeah.
Okay.
Clamps are, you know, if you're gonna go ahead and, you know, run in hole on a well, you might as well do it
Yeah.
right.
Because you're not going to lose the clamps down hole like you could use
No,
bands.
bands are, you know, they're no fun. They can
Mhm.
get stuck in packers, those kind of things, and then that creates a whole another issue.
Gotcha. Okay. And then one of the last questions, you already answered it, but we already got it in about the welding. So say you damage the cap tubing or you need to add to it. Do you do a splice or do you prefer a
You
weld?
can do a union, but you know, again, you're limited on a union. Typically a weld is preferred.
Preferred.
Right.
Okay. Okay. That's
And it's the same as the tubing, if not greater. You know, they can test it, the whole 9 yards, check it, make sure it's good, and then run it home.
okay. And with that, how many welds would you put in a one string before you?
So that's
say
a
too much?
trick question, because that also depends on whether it's internal or external. If
Okay.
it's internal, you know, 3 welds is usually kind of max
Per spool.
per spool.
Okay.
External, you could probably go up to 5.
Okay.
Or you got to remember on those, it's just banded, so it's not, the weld's not holding any weight,
Mhm.
just like an internal would do.
Gotcha. Okay. Very neat. Well, hey guys, Keith, thank you for joining.
yeah,
Thanks
enjoyed
for, giving us
Yeah, it
your
was nice to
knowledge.
see some different scenery than, you know, the Permian for sure.
Well, hopefully, I'd say maybe the weather's different, but it's about the
I
same.
don't know, it's humid.
Yeah.
I don't know.
And guys, thanks for joining. Of course, we'll record this, throw this up on the website in case anybody had to get off early or
Right,
somebody missed it. Again, thanks for joining us. Thanks for taking the time. And Keith, thanks for making the way down here to
Yeah.
talk about cap tubing.
Oh, yeah. Thank y'all.
Yep. Thank you guys. See ya.